One of the most common types of fascinating and enigmatic events in the universe are black holes. They are enormous entities, weighing between 2 and 4 million times that of the Sun. But at the same time, they were virtually invisible to us until recently. We knew very little about them. However, as a result of research done over the past 2 decades, we have learned more and more about these enigmatic objects. Michio Kaku recently made a significant announcement, a discovery. We were able to determine what lies inside a black hole. This new information has shed light on particulars that might have gone unnoticed in the scientific world. We have entered black holes and revealed the secrets of these mysterious spaces. If you're interested in keeping up to date with information about the universe and its surroundings, subscribe to our channel. Be certain to enjoy this video and activate the notification bell. Although many of us have a general idea of what black holes are, there are still some gaps in our understanding. In 1916, Albert Einstein published his theory of relativity, which predicted that black holes exist. Black holes were a new concept at the time, purely theoretical, and the scientific community had to wait an additional 50 years to find evidence of their existence. In fact, this event occurred in the 1960s when scientists were studying the constellation Cygnus. During their investigations, they discovered a bright blue star emitting X-rays. They discovered that these X-rays were not moving independently, but were being drawn into a massive black object that the star was orbiting. This is how the term black hole was coined. This discovery was significant because it provided concrete evidence that black holes exist, indicating they were not merely fragments of Albert Einstein's imagination. It also revealed the existence of a magnificent entity in space that we urgently needed to investigate. This black hole was named Cygnus X1 and can be found in the Cygnus constellation, at a distance of approximately 6,000 light-years from Earth. This was no small discovery, as it had an incredibly high density, which gave it a strong gravitational pull. Scientists undertook the search for additional black holes and discovered that there may be approximately 100 million of them in our own galaxy, the Milky Way. However, due to the extreme difficulty in detection, we still do not have a precise number. It appears that several million black holes exist in our galaxy, which makes them very important objects of study. The main concern of black hole research has always been their gravitational attraction, so intense that anything that enters them will be astronomically compressed into a singularity. Black holes act like cosmic vacuum cleaners, taking in everything in their path. One of the most disturbing parts of black hole research is the fact that, if someone were to fall into one, they would be stretched to the point of becoming a single line. This process would occur slowly, and the person would die prior to reaching their final form. As a result, it is safe to say that nobody should venture into a black hole. However, since these objects are present everywhere, there are concerns and questions as to whether we are really in danger. Even though the closest black hole to Earth is 1,500 light-years away, which is still close enough to raise questions and concern, in 2021, scientists managed to publish the first clear image of a black hole, specifically the black hole M87. For several nights in a row, photographs of the black hole were taken. With each image, researchers gathered additional evidence. It was essential to combine the individual photographs to obtain a complete image that filled in all the gaps. Scientists discovered that black holes are not just empty holes in the void, as many people believed. In reality, they are much more complex. To reach the empty part of a black hole, 3 previous layers must be traversed. The first layer is called the event horizon, which is the point of no return. When you cross the event horizon, there's no turning back. The second layer is the photon sphere, which is the region where light travels in the black hole's orbit. Any light entering this region will be trapped and will not be able to escape the gravitational pull of the black hole. Finally, the third layer is the singularity. This is where everything that enters the black hole is astronomically compressed into a point. The singularity, which has infinite density, is a point in spacetime where the laws of physics, as we know them, break down. You're probably wondering, what lies beyond the third layer called the singularity, right? The idea is that, instead of being completely crushed, one would be pulled through a black hole tunnel, through the ring of fire, and emerge somewhere else, through a white hole, in a parallel universe. This tunnel is known as the Einstein-Rosen bridge. This theoretical bridge is a wormhole, a passage through spacetime that connects 2 separate regions of the universe, or even 2 parallel universes. To understand how this works, we must understand the concept of spacetime in Einstein's theory. According to this theory, space and time are not separate entities, but are connected, forming a 4-dimensional fabric known as spacetime. Objects with mass warp space, creating a gravitational field that affects how other objects move. To visualize this, we can imagine a sheet of paper representing spacetime. If we place 2 points onto the paper and draw a line between them, we are representing how objects move through spacetime. Now, let's consider folding the paper in half and establishing a shortcut between those 2 points. This basic idea is what is known as a wormhole, a means of getting around or connecting two previously inaccessible locations in the universe via spacetime. Although wormholes sound like science fiction concepts, they are actually a prediction of the general theory of relativity. However, none have been found so far. Despite the fact that no wormholes have been discovered yet, scientists continue to search for them, and theoretical physicists remain optimistic. If a wormhole could be stabilized and navigated, it might allow for rapid travel between distant parts of the universe, or even between entirely different universes. However, creating or maintaining a stable wormhole is not a simple task. According to current theories, wormholes would require what's known as exotic matter, a type of matter with negative energy density, to keep the tunnel open. This kind of matter has never been observed, though some quantum theories suggest it could exist under specific conditions. Even if wormholes could be stabilized, there are numerous potential dangers. For example, any particle entering a wormhole could cause it to collapse, making safe travel nearly impossible. In addition, time travel paradoxes may arise. If wormholes connect different times as well as places, then the laws of causality, where cause precedes effect, could be violated. This brings up another intriguing topic in black hole research: time dilation. As predicted by Einstein's theory of general relativity, time passes more slowly in stronger gravitational fields. Near the event horizon of a black hole, gravity is so intense that time effectively slows down for an observer close to it, compared to someone far away. In theory, if you could hover just above a black hole's event horizon and then return to Earth, you would find that much more time had passed for everyone else. This phenomenon, often referred to as gravitational time dilation, blurs the lines between science and science fiction, but it is very real, and it has been confirmed experimentally using atomic clocks in different gravitational conditions. As we continue to study black holes, new mysteries arise. One of the biggest puzzles in modern physics is the information paradox. According to quantum theory, information about matter that falls into a black hole cannot be destroyed. But classical black hole theory, based on Einstein's equations, suggests that everything entering a black hole is lost forever. So, what happens to that information? This question has led to debates among the world's top physicists, including Stephen Hawking, who proposed that black holes might emit radiation, now known as Hawking radiation, which could eventually lead to the black hole evaporating. But if the black hole disappears, where does the information go? Can it be recovered? Or is it truly lost? These questions remain unanswered, but progress continues. With new technologies like the Event Horizon Telescope, space-based observatories, and future gravitational wave detectors, we are pushing closer to uncovering the secrets of the universe's most extreme and mysterious phenomena. Black holes are no longer just theoretical curiosities. They are central to our understanding of the cosmos, of gravity, of time and space, and perhaps even of our own existence. They challenge the limits of human knowledge and inspire us to explore further, think deeper, and imagine beyond the visible. Directly observed, the reason for this is that wormholes are inherently unstable and would collapse almost instantaneously. However, if a stable Einstein-Rosen bridge existed, it would mean that black holes are not only cosmic devourers but also portals that could link us to other parts of spacetime. The question then arises, could we use a wormhole to travel through space and time? Although this is still the subject of speculation and has not yet been determined, the theoretical potential of wormholes opens the door to exploring fascinating concepts about interstellar travel and the link that exists between different parts of the universe. What do you think about it? Do you think wormholes are mere speculation? I hope you liked the video. If so, don't forget to click the like button and sign up for the channel so you don't miss more content like this one. See you in the next video, and thank you so much for watching as we continue to explore the depths of our universe. Black holes continue to be one of the most compelling frontiers. While we've made significant progress in understanding what they are, how they form, and the effects they have on surrounding matter, there is still so much we don't know. One of the most exciting questions scientists are now asking is whether black holes could be used as a form of energy source. Some theories suggest that the immense forces of gravity that surround a rotating black hole could be used to generate energy. This concept, known as the Penrose method, suggests that if we could send matter into the region just beyond the so-called event horizon, the ergosphere, we might be able to extract energy from the rotation of black holes. While this remains purely theoretical, it currently opens the door to mind-blowing possibilities in future space technology. Another avenue of research is Hawking radiation, which was predicted by physicist Stephen Hawking. According to this theory, black holes are not completely black. Instead, they emit tiny amounts of thermal radiation due to quantum effects near the event horizon. Over extremely extended periods, this radiation could cause black holes to slowly evaporate and disappear. If we could directly observe this phenomenon, it would provide valuable insights into how gravity and quantum mechanics interact, possibly leading us toward a unified theory of everything. It's possible that black holes play a much larger role in the formation and evolution of galaxies than we ever imagined. At the center of almost every major galaxy, including our Milky Way, lies a supermassive black hole. These giants can be billions of times more massive than our Sun. Scientists believe that the gravitational influence of these black holes may regulate the formation of stars and control how galaxies grow and evolve over billions of years. With the assistance of powerful new tools like the James Webb Space Telescope and the Event Horizon Telescope, we are just beginning to peel back the layers of these cosmic giants. Each discovery leads to more questions, extending the boundaries of our knowledge and challenging the limits of human understanding. The journey into black holes is about more than just science, it's a search for meaning in the vastness of the cosmos. Are they gateways to other universes? Do they assist us in comprehending time travel? Or are they just the universe's way of recycling matter and energy? We might not know everything. However, one thing is certain: black holes are no longer just the stuff of science fiction. They are real, they are powerful, and they hold some of the greatest secrets of the universe. So stay curious. Keep asking questions. Keep exploring the universe. If you like this journey through the cosmos, don't forget to give the video a thumbs up, share it with fellow space enthusiasts, and subscribe for more mind-expanding content. Until next time, keep looking up, and remember, the universe is always listening. As we venture further into the unknown, we begin to realize that every answer brings with it a dozen new questions. What lies beyond the event horizon? Could black holes connect not just regions of space, but entirely different dimensions or timelines? These are no longer just the musings of science fiction writers, they are active areas of theoretical physics and cosmology. In the quest to understand black holes, we're also learning more about ourselves, our curiosity, our desire to explore, and our endless need to seek meaning in the cosmos. From ancient civilizations staring up at the stars to modern scientists decoding the fabric of spacetime, the journey has always been driven by wonder. And now, with instruments like LIGO detecting gravitational waves and the Event Horizon Telescope capturing the first images of a black hole, we're living in an era where theory is beginning to meet reality. We're witnessing the invisible made visible, the silence of space breaking into a cosmic whisper that tells us, there is more. The more we learn, the more we're humbled. The universe is vast, mysterious, and often paradoxical. But that's exactly what makes it so captivating. So whether you're a student, a dreamer, a scientist, or just someone staring at the stars in awe, remember, you're part of this journey. Your curiosity fuels the next discovery. If today's exploration inspired you, let us know in the comments. What do you believe lies at the heart of a black hole? Are they endings, or beginnings? Make sure to subscribe and turn on notifications, because our journey through the stars has only just begun. In upcoming videos, we'll explore dark matter, the multiverse theory, and the edge of the observable universe. Until then, keep your mind open, your questions burning, and your eyes on the sky. Because out there, among the stars, the next great mystery is waiting to be uncovered.